See this question. Show that the maximum horizontal range is 4 times the maximum height attained by the projectile when fired at an inclination so as to have the maximum horizontal range. Say, let's take a projectile. So suppose this is the projectile. Say it is the V0 is the velocity of projection and theta is the angle of projection. So the formula of range is, we have just found, V0 square sine 2 theta by g. So when this is going to be maximum, this is going to be maximum when this is 1. So R max is V0 square by g, and when it takes place when sine 2 theta is 1 or 2 theta is 90 degree or the angle of projection is 45 degree. And at this angle, what is H max? The formula of H max is V0. So when theta is 45, this is going to be sine square theta. Sine theta is 1 by root 2, sine 45 is 1 by root 2. So sine square 45 is 1 by 2. So this is 4g, which is R max upon 4. So R max is 4 times H max. That's what we have to prove. Alright, let's take the next question. The question says, show that there are 2 values of time for which a projectile is at same height. Also show mathematically the sum of these 2 times is equal to time of flight. See what the question is saying, that if you have a projectile, suppose this is a projectile motion, then suppose this is the velocity of projection V0. Then if you take any height, see, if I take any height, suppose I take this height, then the body lies at this height, the body is lying at this height at two time instant. At one time instant body is here, and next time the body reaches the same height at this point. When this is the path traced by the projectile, right? So the body lies at height h at this instant, and next time body lies at this height is this point. Both of these points on the path are at the same height. The y coordinate, the height of this height is also h, and this height is also h. So, and these 2 points are achieved by the body at 2 different time instant. At 2 different time instant. Suppose h is the height of the body, and suppose t is the time at which body is at height h. So you have the equation, y coordinate is given by V0 sine theta t. So I want the time instant at which this y is h. So you have this equation. So I can get time from this equation. So this is what? This is gt square 2v0, alright, plus 2h equal to 0, and the time instant at which the body lies at this height h will be satisfying this equation, or you can say the root of this equation will give you the time instant at which body will be lying at height h. And since it is quadratic equation, then of course it will have two roots. It will have two roots, and those two roots will be the time instant at which the body will be at height h. So this is proved that there are two time instant at which body lies at some height h, because this is quadratic equation, so it will definitely have two solution, right? Okay. And moreover, we can say both of the time will be physically acceptable, because both will be positive. Both will be positive because the product is product of those two time t1 t2 is 2h by g, and sum of this t1 plus t2 will be, you'll use the property of quadratic equation. So you see, product is positive, sum is positive, so both the time are physically acceptable. It can happen only when t1 and t2 both are positive. See, if product is positive, sum is positive, that can happen only when t1 t2 both are positive, right? So that means both of the time t1 and t2 is physically acceptable, and the sum of the time instant, and what is this? This is time of flight. This is equal to time of flight. Alright, so that's what we have to prove. Sum of these two time is time of flight. Let's move to next question. Let's do this question. A projectile is fired horizontally with a velocity of 98 meter per second from the top of hill 490 meter high. Find the time taken by projectile to reach the ground. Second question is distance of the point where the particle hits the ground from the foot of the hill. And then the question is velocity with which projectile hits the ground. Let's try to do this question. Let me draw the figure first. So this is the ground, and suppose I don't know how to draw a hill, but I'll draw it. Suppose this is the hill, and height of hill is 490 meter. And from the top of the hill you are projecting the body in horizontal direction with 98 meter per second. So under the action of gravity, the body is going to move like this. Suppose this is the figure. You can draw a better figure. It's not good figure. So suppose this is the projectile, right? This is the velocity of projection. This is the velocity of projection. Now we have to find out time taken by the body to come to the bottom. See, over here the very important thing is let's choose a coordinate system. Let's choose a coordinate system. Suppose I choose this coordinate system. See, you can choose coordinate system as per your freedom. It's not like I have chosen this coordinate system, so you should also choose the same coordinate system. You can choose a different coordinate system also. That's not an issue. You can choose the coordinate system with origin over here also. No issue. The only thing, few steps will go different, but the rest of the thing is going to remain same. Suppose I take this coordinate system, right? So this is the origin, and what's the coordinate of this? Suppose this is, let's take this as R. So the coordinate of this point is R, and since this is the origin, this is 490 below x-axis, minus 490. So see, initially you have only Vx, the initial velocity lie in x direction, which is 98 meter per second, and there is no force acting in x direction, so this velocity will remain constant. So Vx will always be 98 meter per second. There won't be any change because there is no acceleration in x direction. But Vy will keep on changing. Initially your Vy naught is 0, so it is 0 1 by 2 gt square. Vy naught minus 1 by 2 gt. That's the velocity in y direction. Oh, sorry. 0 minus gt. And from here you get x as, it's v cos theta, or say vx, x will be, this is dx by dt. So x will be 98 t, and if I put any constant, that constant will be 0. Why? Because x is 0 at t equal to 0. X is 0, the body is here at t equal to 0, and at this point x is 0, y is also 0. So c will be 0. So x coordinate is going to vary like this equation, and this is minus gt, and this is equal to dy by dt. So y is going to vary like 1 by gt square, 1 by 2 gt square plus c2, and c2 will also be 0. Why? Because at t equal to 0, y is 0, so c2 will also be 0. So y is going to vary like 1 by 2 gt square, and g, question says you take 9.8, so this will be minus 4.9 t square. Put the value of g, 9.8. Okay. So the question says, what is the time taken by projectile to reach the ground? So ground here is, what's the y coordinate? Minus 490. So let's find out what's the time taken so that y becomes minus 490. This is 4.9 into t square. So t is what? It will be 100 second. 490 upon 4.9, that is 100 second. And during this time, this r is going to be, whereas 98 time is 100 second. During this 100 second, by the time the particle falls to ground, the horizontal distance traveled would be 98 into time of this flight. So this is 9800 meter. It's very large. Okay. Velocity with which particle hits the ground. See, your Vx was 98. It will remain 98. Vx will remain 98 because there is no acceleration in x direction. Whereas Vy is minus gt. So this will be minus 10t, or t is what? 1000. I think I have committed a mistake. That's why it is so high value. In fact, this is t square, and t will be 10 second. Got the point? This t is 10 second. So this is 980, and this will be 100. So 98 on this side and 100 on this side. So net velocity would be, sorry, g is not 10, g is 9.8. So 98. So 98 on this side. So net velocity would be 98 square plus 98 square under root 98 root 2 meter per second. Okay. So that's the velocity with which the body is going to hit the ground. Okay. And this angle will be